Today on Capechi's Corner, we're going to look at parent functions and transformations. Now, a family of graphs is a group of graphs that display one or more similar characteristics. The parent graph, which is the graph of the parent function, is the simplest of graphs in a family. This is the graph that is transformed to create other graphs in a family of graphs. So I know that's very wordy. Basically, it means that we're starting with the parent graph, and we're going to enlarge it, or we're going to narrow it, or we're going to shift it right or left or up or down. But we have our starting point. Our starting point is our parent graph. Now, here's a great kind of chart that will be good to look back to when you start to graph. This constant function, we don't do too much with. That's just a horizontal line where A is any number. So we can shift that up or down, but we don't really need to think about a parent graph in that regard. But it's there if you need it. An identity graph, this is a line. It's a linear function. So the basic graph we have, our parent graph, which is listed there, is f of x is equal to x. So it starts at 0, our y-intercept is 0, and our slope is 1 over 1. So we're going to go up 1 to the right 1, and then we'll make some changes as we go. Now, when we look at absolute value functions, we talked about this last lesson. So what's going to start with is we're going to start with this f of x is equal to the absolute value of x. Now, that's going to change regarding, depending on whether we have something outside, like is something going to be written here, or something inside, is something in front of, but that's our basic, that's our starting point. We're starting at 0. 0, 0 is where our vertex is. And then again, because it's absolute value, depending on the numbers that you use in the parent function, those numbers will always be positive, but we might have to flip that over an axis, and we'll see some examples of that. Now, quadratic functions, a quadratic is something to the second power. So our quadratic parent function is f of x is equal to x squared. Now, again, depending on what we put in the end or what we put in front of it, we're going to shift or change that quadratic function. Okay, transformations. Transformations of a parent graph may appear in a different location, flip over an axis, or appear to have stretched, which means kind of get wider, or compressed, which means kind of get a little bit more narrow. The transferred graph may resemble the parent graph, or it may not. Usually it does. You might not recognize it right away, depending on how the shifting is. But everything we have that we're going to do in this class, we're going to be able to see a good comparison. Now, a translation is something that moves up, down, left, or right. So the first thing we're going to look at is we're going to look at our absolute value here. So we're going to give examples of each. So our absolute value parent graph is f of x is equal to the absolute value of x, okay? So if we have a number outside here, right, if we add something here, either plus a number, plus 7, minus 3, that's going to change that parent graph, and we're going to go left or right depending on what's there. So what we have too on the outside here is we have a plus 2 on the outside. So what that means that this parent graph y is equal to absolute value of x is going to go up 2 units. Now, when we go through this, you can also make a table to double check your values. So I started at 0, 0. I'm going to go up 2 units, right? That's where my parent function was. The same thing here. My next value started at 1. I'm going to go up to here. I started at 1 on the other side. I'm going to go up to here. So that is how our new graph is going to look. So let me get some lines again. So we just took our parent function and we just moved it up a little bit, little shift up. When a reflection flips a figure over a line, we call that the line of reflection. So if we have something, we can flip something over the graph over the x-axis and the y-axis. It really depends on where that negative sign is. So let's look at this example here. We have a negative sign in front of our x squared. So that is going to look like this example right here. Okay, so what's going to happen is this is our parabola, right? This is our quadratic, which usually looks like this, starting at 0. So again, parabola, we would look this way. I'm just doing a little estimate. So we're taking that parent function. The only thing we did was we multiplied it by -1. So if you were to do a chart of values, all it's doing is reflecting over that x-axis. So it's just going to look something like that. That's an estimate. Okay. Now let's move it to the next example. A dilation shrinks or enlarges a figure proportionally. When the parent function is multiplied by a non-zero number, so anything other than zero, the slope of the graph changes, right? You know, you've graphed a lot of lines and you never really thought about it. When a non-linear parent function is multiplied by a non-zero number, the function is stretched or compressed. Okay, so we can have something when we have coefficients that are greater than 1, it could stretch vertically. Coefficients that are a fraction can be compressed. So we have a lot of different things that can go on right here. Okay, so we know, and I'll kind of just sketch that. We know this is our parent function, right through here. Right, that's our parent function. So I'll kind of just sketch that very quickly just so you can see. Now, if we were to graph y is equal to 4x, right, we would have our 0 here. My slope is up 4. 1, 2, 3, 4 over 1. I can go down 1, 2, 3, 4, down 1. So you can see the slope is definitely steeper here. So when I use my line tool here, you can see that new line is definitely steeper, and that's because of that 4 in front. That 4 is greater than 1. Okay, so this happened is the slope is now steeper. Okay, from our parent function. Let's just go back up here, and I stated it, but I didn't actually write it. So what happens is when we reflect here, we have a reflection over the x-axis in this case, reflection over x-axis. Now we're going to take a look at some examples, and we're just going to kind of see how it goes, like what's happening. So in number 4, we have that absolute value of x plus 3. Now this 3 is inside. Because it's inside, we're going to say we're going to be translated to the left. Translated to left 3 units. So I'm going to move to the left, and then I'm going to have my parent function will kind of be copied at this point. It's just to the left a little bit. So that's what this one's going to look like. So again, I think in the beginning, it's especially helpful if you just have your notes out and go through this, because these are hard to remember, and I'm not really about memorization. I think it's easier if you understand something. You can also make a little chart, right? Make a little XY table, and that might help you as well. Okay, and number 5, we have y is equal to x squared minus 4. So because of this minus 4, it's outside, we're going to go down 4 units, down 4 units. Okay, so we have down 1, 2, 3, 4. And then we'll have our quadratic. We're all set. Now, again, for the next one, we have an absolute value, but we have that negative outside. So what's going to happen is we're going to have reflection across the x-axis. So we're going to still start at 0, right? We have no shifting up or down. And then we have our points there. So we are going to just have a reflection right across that x-axis. Okay. So now, again, we've talked about lines a lot, right? We know this is going to be our parent function this way, right? All the way through there. Now this one, let me actually make that in blue. This one, our new line, and again, you've graphed this, probably you've graphed this line a lot through your math career. I'm going to start at 0, but my slope is going this way. So when I have my line, what happened there? Well, I actually, you can say either way. You can say I reflected across my y-axis, Or you can even say I reflected across my x-axis. In this case, either one will work. That's exactly what you did. But with lines, we don't really think so much about reflection or shifting. We usually just graph it because it's an easy thing to graph. Okay, let's look at our next example. We have y is equal to 2x squared. So here's our parent function. Again, this is a parabola. So what happens is on this one, because this 2 is in front, we have a dilation. And because that 2 is a whole number, we're going to stretch it. We're going to make it look bigger. And it's going to stretch vertically. So again, we're going to be here. And then here comes the stretch is going to be here. Now, again, you can pick points if it makes it easier for you. So it's going to be just a little bit more narrow there in our slope. Okay, let's look at our last one, number 9. Now this, again, this 1/3 inside. We haven't seen a fraction yet. So what happens inside is that's going to be a dilation, but it's going to be stretched horizontally. So I have 0, 0. And this is, like I said, I think really just making an XY table is probably just as easy. If you're doing this and this makes sense to you and you can remember the shifts up, down, left, or right, then that's great. But a lot of times you just need 1 or 2 points to kind of see what's going on. So let's just say if I use 3 and I substitute that into my original equation, then that would give me 1. If I use -3, that would also give me 1. So I'd be 3, 1 here. -3, 1 here. And again, you're going to see it really got stretched out. It's really stretched there and there. So that's it. So I would just say with these, just use your notes and be patient with yourself if you don't understand it right away and just practice as much as you can. Okay, have a great day.